When it comes to your cloud apps, being online isn't just a feature, right? It's everything. But there's this constant threat out there that's designed to do one thing: knock your services offline. Today, we're going to dive into how you can build an automated shield against one of the biggest disruptions on the internet.
So let me just ask you this straight up. What do you think is the single biggest threat to keeping your online service up and running for your customers? And it's not always about someone stealing your data or some super complex infiltration. Sometimes the biggest threat is just getting completely, totally overwhelmed.
And that's where this thing called a distributed denial of service, or DDoS attack, comes into play. Look, the goal here is brutally simple. Flood your application with so much junk traffic that it just runs out of resources. What happens then? Well, your real users, the people you actually want, can't get in. It's like the digital front door is jammed shut and your service is, for all intents and purposes, offline. Yeah, you can really think of it like a digital floodgate has been thrown wide open right at you. Honestly, these attacks are one of the biggest availability and security concerns for anyone moving their applications to the cloud, and for a really, really good reason. So who's the target here? You might think it's just the big companies, but the real answer? It's pretty much everyone. If your service, your website, your API, heck, anything has an endpoint that can be reached from the public internet, then it can be targeted. It's not a matter of if you're a target, it's really a matter of when you might get hit. That all sounds pretty grim, right? I get it. But this is where the story pivots from the scary stuff to the solution. We're talking about Azure's automated shield, a defense that's incredibly powerful, but also surprisingly simple to get going. And when I say simple, I really mean it. This is basically the definition of turnkey. You can enable Azure DDoS Protection on any virtual network you have, whether it's brand new or has been around for years. And get this, you don't have to change a single line of your application's code or reconfigure your resources. You literally just flip a switch. That's it. So how does this magic actually work? I mean, what's really happening under the hood once you flip that switch? Let's pop the hood for a minute and take a look inside this incredibly smart defense system. First things first, it's always watching. Your application's traffic is being monitored 24 hours a day, 7 days a week. It's like having a silent, vigilant guardian that's constantly on the lookout for the telltale signs of a DDoS attack. And the second an attack is detected, the mitigation kicks in instantly and automatically. Okay, but it's not just a dumb guard at the gate. It's not just watching, it's learning. And this is the really clever part. The system uses what's called intelligent traffic profiling to figure out what normal traffic looks like for your specific application. This is an absolute game changer compared to older systems that use these static, rigid rules. Those could either block your legitimate users or let attacks slip through. Instead, this creates a custom, tailored profile of your traffic patterns, and then it adapts over time as your service grows and changes. So it's not a one-size-fits-all shield, it's a bespoke suit of armor. Now let's talk layers for a second. Think of your application like a building. Azure DDoS Protection is fantastic at securing the foundational layers. That's the network and transport layers, or layers 3 and 4. It stops the attacks trying to just bust down the main doors. But for a truly complete security setup, especially against those tricky attacks that target what's happening inside your web apps, well, you need protection at the application layer, layer 7. And that's where a Web Application Firewall, or a WAF, comes in. They work together like a perfect team. Okay, so you're on board. You need this shield. The next logical question is, which one? Azure actually gives you a couple of different options, so you can find the perfect tier for whatever your needs are. The choice really just comes down to how wide you want your net to be. If you want the whole shebang, a comprehensive plan that covers every single resource inside a virtual network, you'll go for DDoS Network Protection. That one also comes with some really valuable extras, like access to a rapid response team and cost protection. But if you need to be a bit more granular, maybe just protect a few specific things, DDoS IP Protection is a pay-per-IP model that gives you that core protection for individual public IPs. But hold on, let's go back to one of those extra services, because this one is huge: cost protection. Think about it. When you get hit by a DDoS attack, your application might have to scale up like crazy to handle the load, and that costs money. Well, Azure gives you a 100% service credit for those costs. I mean, that's just massive. It's total peace of mind for your budget. All right, so having a great tool is awesome, but a tool is only as good as the strategy you build around it. So let's talk for a second about how to really fortify your setup by using some fundamental best practices. It really just comes down to 3 big ideas. First, from day one, design for resilience. Build redundancy right into your architecture. Second, always use that multi-layered security approach we talked about. Combine network, application, and data protection. And third, and this is so important, have an incident response plan ready before you need it so your team knows exactly what to do and can act fast. And really, this is what it all boils down to. Great security isn't just about buying a product off the shelf. It's about that perfect combination of powerful tools like Azure DDoS Protection working together with smart, resilient architectural design. After all, the tool is the shield, but your design, that's the fortress. And that leaves us with one final pretty important question you've got to ask yourself. When you look at your own services, your own architecture, and your own level of readiness, is your application really ready for an attack? Because with the right preparation and the right tools, the answer can and absolutely should be yes.